Hello, Forecaster here again, and we are back for episode 45 of the Railcraft server Let's Play. And as you can see, we are back in the test world where we were working on the reactor in the last episode. So, oh, maybe I finally got rid of that microcontroller. Great. Okay, so I want to attach an adapter to the reactor access hatch. Although first I'm going to place another one right here so I can still access the reactor. And here we're going to have a look at the component list, and it doesn't look like the hatch is actually accessible. Maybe it was a redstone port. I'm pretty sure there is a way to... Ah yes, there we are. So the redstone port allows us to access the reactor functions, and we can use that to, for example, get the heat level of the reactor, and we can get the max heat level of the reactor. I thought it was the access hatch for some reason. But okay, so now that we have the equipment we need set up, we're going to have to start working on the actual program, and I haven't planned anything ahead of time. But we're going to go back to IntelliJ, and here we're going to add another component. We'll call it reactor, and then say component, and then it was reactor redstone port. We can use that to get the heat level and such. Then we're going to want a main loop. Did I just write EMD? There we go. What is that? All right. Whoops. While should be do. Not then. That's for if. Now I'm going to want to define a function which we're going to call onInterrupt. And then we're going to set run to false, and then we're going to need the event library, and we're going to do event listen interrupted and set that to onInterrupt. So what we're doing here, if you don't know, is we are registering an event listener that is going to call this function when something triggers the interrupted event. The interrupted event is triggered when you press Control-C, and it allows us to use that to shut down the program, which is what it's for. and that is going to set run to false, which is going to stop this loop from running. So this is going to be running, which is going to keep the program alive, and we are going to do stuff in here in this particular program, but sometimes you want a loop that just waits and just keeps the program running. Then we need to remember after this, we have a bunch of line breaks that we don't need. We're going to want to do an event ignore interrupted on interrupt. And this is important because when the run loop ends, when run becomes false, this is going to stop looping here and is going to run to the end of the file. And if we don't have this, while our program isn't running anymore, and we would be returned to the command prompt in OpenOS, this function would still exist on the system and would still listen on the interrupted event. So when we press Control-C, it's going to keep calling this function. And while in this particular case that wouldn't really do anything, but if we, for example, had a print in here, so we said print shutting down, or we had it like this, and we didn't have this, even after our program has shut down, when you press Control-C, it will still print shutting down wherever we are. We could be in a different program and it would still do this. And we definitely don't want that. So we need to unregister our listener and disassociate this function with the event. So we stop listening to the event before our program ends. In our main loop, we are going to want to, the primary function of the program is to control the flow of coolant to the processing system depending on the fluid level available. And the other primary function is to control the reactor based on that fluid level as well. So we have two functions, two actions we want to perform, both depending on the fluid level. So we want to do those checks in this main loop. So we have the tank, and the tank, let's see, let's go back to Minecraft for a little bit. We'll go back into the Lua prompt and we'll do component, was it? That's the MFSU. No. Let's do the list again. So what's the... Oh yeah, the tank is the transposer. Yeah. And then this will have get fluid in tank sides east right. Pretty sure there were right, get tank level. On the east side. And then we had get tank capacity. Right. So those are the ones that we want to use. So here we're going to define, actually we can probably define these outside of the loop, so we keep them in the program. Might as well. So we have level, which we're going to initialize on 0 or as 0. That does not say level. And then we have capacity. We're also going to initialize at 0. Actually, the capacity isn't going to change. So we don't need to recheck that every time. So we're just going to do this once when the program starts. We're going to set the capacity, and then level, we need to get each loop. So tank gets tank level, and then we can probably say up here we'll do that, and then we'll do actually might as well do that, and then we can just do tank aside like that. So we don't have to change that in a bunch of places if we oh geez, if it ends up in a different side later. So now we have the level. We can calculate the actually, we only really need the percentage. So why don't we set the level to that immediately? So we want the tank level divided by the capacity, and that should give us a percentage, well, a decimal percentage. So we do print, and then print the level, and then we'll do an OS sleep for 10 seconds for now. Then what we're going to do is I want the okay, let's see here. First I need to check that the config is set up correctly. I need to go into the okay, I already have that open, so let's search for buffer. Buffer changes is currently true. I want that to be false. Minimize that. And then I'm going to have to restart Minecraft. Because I want the I want to be able to edit the script in the world directly and push this file here to the game without having to fiddle with pastebin or other stuff. And I can do that with IntelliJ, which is convenient. So we're going to set that up for this particular script right now. First, I'm going to go into the world directory. I'm going to the world, and I have a bunch of storage devices here, and I don't know which one is the hard drive, so I'm using currently. So I'm going to have to wait for the game to boot up again so I can look at that. But in IntelliJ, we are going to go into deployment, and this feature is only available in the full version of the program. And in here I can define a bunch of paths that it's going to upload files to. And it can upload from a local directory to another local directory. So you can see I have a profile here called local, which I've set to the OpenComputers storage folder in the instance that I'm using for the Railcraft Patron server. And then we have the world directory called saves, and then the test world that I'm using. And in the OpenComputers directory is where all the hard drives and disks are kept. So this is the default path that all of these mappings use in the deployment path. And then I have linked to a file in my project to a remote file in this folder. And you can see here the addresses of the storage devices. So now Minecraft has booted back up. And loading up the world. And we're going to add a new mapping to this computer that I have in this world that I'm using for the reactor. So now the world has booted up. Let's switch back to Minecraft. So here we have the computer, we have the hard drive here, and we can see the beginning of the address in the tooltip there. It starts with 75F. So I'm going to go into here, and we have, there is the directory name. So we're going to add a new mapping, and then in the project here, we're going to add that folder, and then we're going to specify the file. So what do I call it? Reactor Manager. .lua. So you can specify a file, but it doesn't allow selecting a file by default. And then as the deployment path, we're going to paste that specific drive that I just copied and pasted from the name of from the whatchamacallit, the Windows Explorer is what I was looking for. And we're just going to go home and then specify the same name, so reactor manager.lua. And then as the web path, we can set a / so it stops complaining, although that field is irrelevant for this because this is not a web project. And normally you can use this to upload or push files to a web server for deployment, hence the name of the feature. So what happens now is I can right-click either on the file in here or on the tab here, if I aim correctly, and then upload to local. And you can see that it uploaded the file, although it really just copied it within my system. And if I go into here, you can see that I have automatic upload ticked here, which means that when I press Control S, while IntelliJ doesn't use, it saves automatically as soon as you change anything. When I press Control S with automatic upload enabled, it's going to trigger an upload for any file that is changed in the project since the last upload. So if we go back to Minecraft now, and we go into the computer and do an ls, you can see that we now have the reactor manager file on this computer. And if we do edit, it's going to contain everything that we have in that I wrote in IntelliJ. So now I can edit the code in IntelliJ and quickly push it to Minecraft to test. So that is very handy. So now if we run the reactor manager, it's going to print the tank level every 10 seconds. So we have about 31%, just above 31%. And if I go into here, we can find a fluid container. I already had some. We plop that in there, and then next time we're now down to 28%, I think that says. I can't really tell. Can I? Yeah, that says 28%. Handy being able to zoom. I just had to find the hotkey for that. And we can interrupt the program by pressing Control C, and then when the loop, the timer, the sleep expires, it's going to end the loop. Probably want a tighter sleep when we have the actual program later on. So back to IntelliJ. Now, instead of just printing the tank level, we are actually going to want to do something with it. So we're going to remove this print. Whoops. And we are going to say that if level is less than 0.5, then we're going to call on the reactor control, which is a redstone IO block. So that is going to need a side as well. So we're going to define a new side here, which also happens to be on the east side. We're going to call that power side because that is the power switch for the reactor, basically. So we're going to set output to 15 on power side to enable the reactor. If the level is not below 50%, we're going to set output to 0 on power side to turn the reactor off. And we can test this immediately. And now we probably want to lower this so it checks more often. So we can set this to, say, 1 second. And we won't print... Actually, we can still print the level just so we can see what is going on. And we can actually also, I think, math round that to do that, and then times 100 to make it display as a proper percentage. Don't have any parameters or any argument documentation for that, which is slightly unfortunate. So now if we go back to Minecraft, we run the reactor manager. Oh, right. Whoops. We need to end the if statement. So now we go back here. We should be able to run the reactor manager. No, invalid side. 27. 27 is there? What? Oh, is the side first? The side is probably first. I most likely messed the argument order up there. That's supposed to be 0. Okay, so now then, let's try again. Oh. Well, the reactor is running. But the program isn't, so we want to turn that off. Hopefully this gets us the correct... Oh no. Crap. Okay. Right, so the program errored because math is not a thing. What was... How did you round things? Was it just round? No, I'm pretty sure... Is math a library? Let's Google this. Because I do not remember that off the top of my head. Maybe there isn't a built-in... Or maybe it was just round. I have a... It feels like I've used that. Let's try with just round. Now that I destroyed this, we're going to have to update this, because that address will have changed. I guess I could have just broken a block in the reactor, but it disabled it. So now we should be able to do this again. No. As you can see right there, it crashed because round is nil. So it's not just a function either, global function. And here you can see what happens because our program shut down before properly exiting. It didn't unregister the listeners. So we have these additional printouts, which is annoying. And the only way to get rid of them is to use either, I think you can go into the Lua prompt and register the function as many times as you have these registered, or you can just reboot the computer, which will clear the memory. Okay, so let's skip the rounding for now. I'll have to remind myself how I've done that later on. So I'll just print the decimal level, and we'll do a quick reboot just to... Oh, right. There's no EEPROM in there. It's not going to boot up without that. Need the BIOS there. Okay. So we're just about out of time. In fact, we've gone a little over time, but oh well. What? Why is the hard drive empty? Did it boot from the disk? Not supposed to do that. Okay, yeah, there we go. It just booted from the floppy disk for some reason. What? Oh. I don't require sites. Let's fix that quickly. Like so. We'll go back to Minecraft, and we'll now have 2 shutdown events stirred. So now we have 90%, so it's not turning on the reactor because we have more than 50% worth of fluid in here. So let's have some of it processed. So we'll drain a bunch of it. Can put that back as well. And as soon as it goes below 50%, these should now be... Okay, so these... Okay, that's heating up, right. So we're getting close, so this should be printing out percentages. And we're approaching 50. We'll see if this works properly, and then we'll end the episode. So the reactor should turn on now. We'll turn this off. And then we went above 50, and the reactor turned off. So that control is working fine. So in the next episode, we'll continue working on this, I suppose. Hopefully at least someone is finding it interesting. So this is starting to cool down again. It seems that this has been fixed where this wouldn't cool down when it wasn't. It would stay at the just below the working temperature, which means that we're going to want to design this so it runs in long bursts instead of in pulses like you could in 1.7, to conserve or to be as efficient as possible. So we'll have a look at that too. But for now, we're going to end this episode, and I will see you in the next one.